the computer. All right, so week 4 and most of the workshop questions that we see here, you will see them, most of them in your future workshop. And the workshop questions are mainly about the graph. So here is the definition of the graph. So graph is this one, G. A graph G is including vertices and edges. So vertices are the elements and the edges are those ones that they are like edges between the vertices here. So we typically write the edge like in this form, where U and V are vertices. Vertex, U is a vertex, V is a vertex. Now, here, the first question is A, B, C, D. So I've got this one. I've got BC. I've got CD. I have a DA. I have AC. So E5, E5. So definitely I can do this one as well. So there is no edge here. There is
what is that circle in the middle?
Pardon?
That circle here in the middle.
Which one?
This.
Let me, this is, okay, which one do you say? This one?
Yeah.
I just said that this one is not a vertex. Okay.
All of them because two lines are crossing, that's right.
So I want to say that you can do like from here to here, or you can do from here, or you can do from here. So we've got 4 vertices and 5 edges. Edges. Okay, so this has been updated and I don't know how to handle this. Oh, yeah. So, okay, next question. See, just fast as possible. So the diagram of the graph is this graph is a picture showing the dots with the about vertices and lines or curves or a straight line. They are showing edges for us. So like this one, vertices A, B, C. So you just studied today. I think different diagrams can present the same graphs. So the following are all diagrams of the same graph. So as I said, so instead of BD, so you can do this one, so or this one, or this will be again BD here, and you see that this is the same as this one, and but this, can we have this one the same thing? Yeah, this is the same thing as well. So all of these they are showing the same graph. So this, all of them are where A, B, C, D, and E is equal to A, B, and B, C, and C, D, comma, D, A, or A, D, A, C, or C, A, doesn't matter, B, D. Okay, so we've got this one. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 here. Okay, so all of these are the same graph. Okay. Now, graph terminology, and it connects its endpoints. Okay. So, an edge is incident with its endpoints. Okay, a vertex with no incident point edge is isolated, so they like a single point or alone. An edge with both endpoints that like something like this. So this one is the edge. So, and this one is the loop. So loop. So the degree of a vertex is the number that of edge incident with it. So the degree of this one is 1, 2, 3. So sometimes the loop is counted 2, sometimes it's counted 1. So it can be 2. So therefore the degree of this vertex is 2 or 3. But definitely the degree of this vertex is 1. And two edges may connect the same pair of the endpoints. So okay, so the what here? So this one, so this one, so these are parallel. These two edges are parallel. They are called parallel. Two vertices are adjacent if they are connected to an edge. So this and this vertices are adjacent, and two edges are adjacent if they share an endpoint. So this edge, which is a loop, and this edge, they are adjacent or neighbor because they share one endpoint here. Okay, so they have something in common, and this is this one.
Two vertex are adjacent, means the vertex which is forming the loop.
See, okay, so another example. This is these two edges are adjacent. These two vertices are adjacent. And what else?
The first two are adjacent.
This loop or edge, it's technically one edge here. So this edge and this edge, they are adjacent.
Okay, because they are connected in one vertex.
They share at least one vertex.
If any of the vertexes, any of the edges sharing one edge, we call it adjacent.
Yes, yes. Neighbor. Now consider this graph with vertex V, this one, and edge set with this one, where this edge is this one. So do I need, so H M S C. So I've got this one, which I will call it E1, which is this one, Melbourne to Sydney. Old Road is this one. So Melbourne to Sydney, E2. Fed is E3, which is Sydney to Canberra. and scenic is E4, which is the camera to camera. All right, draw the diagram of the, so we just did. This guy, find the degree of each vertex, find all isolated vertices, parallel edges, and loops. Also identify instances of the endpoints of the an edge, a pair of the adjacent vertices, and a pair of, okay, so you can do this. All right, so the degree of just one, the degree of M is 2, or we call it like this, M is 2, degree of S is 3. So E1 and E2 are parallel. All right, so you can continue this question. So because we did here. So yeah.
We can count degree means how many vertices are connected with them.
How many
Edges are connected with them.
yes. The number of the edges that which is
Connected with
incident or it connected to that
point.
To that vertex or point. Now here is the like lots of explanation. Vertex adjacency list. So where so e.g. the graph GVE. So the vertex is HMS. So actually technically is the previous questions. Okay. So E1, E2, E3, so E4. Okay. Vertex is this guy HMSC. Adjacent to H is adjacent to nothing. M is adjacent to SS. So is that okay? Yes, S, because we have two bridges. S is adjacent to M, hello. And C is adjacent to itself and S. All right, adjacency matrix is called like this one. H is 0, HM 0, HS 0. So, you know, adjacency matrix is like rows and columns of the matrix are labeled by vertices. So vertices here. So labeled by vertices. Bad. Okay. In the same order, and so I mean same order, HMS. See this guy, they are in the same order. The entry of this RJ, like here, this one is the entry of the matrix. It incident of the indicates that the number of the edges between those I and J's vertices. For loop between vertex I, the number is recorded, should be recorded as 2. For example, this C to C is this one because we've got this one loop. As I said, in some books it is 1, or in some books it is 2. Yes. Then what else do we have? Incident matrix. So once you are doing your exercises or assignments, unfortunately, you should review these notions. There are lots of notions here. Incident matrix is what? Incident matrix, rows of the are indexed by vertices, row, and the columns must be, the columns are indexed by the edge names. So it means this one, E1, E2. So HD connected to E1, let's H to connected E1. So this is this H, this is H, this is E1. So it's 0. M connected to E2, yes. M connected to E2, so 1. S connected to E3, for example, is 1. S connected to E1 here is 1, and so on. Now, the question. Find a diagram incident matrix, vertex, adjacency, listing, and so for this one. Okay. So can we do this? Vertex. What are the vertices? What are the adjacent to? So I'm going to do like this. Adjacent. So A, B, C, D, E. Okay, F. Very bad. Okay, this. F. So F will be A is connected to this guy. So it has B. A also connected to C, so it has C. What? Undo C. So B has this A, B, C, A, B, C. C has the A, B, Y. So can I do this? It's just one example. C is adjacent to which other vertices? So with it, one of them is just this guy, and the other one is this guy, and so on. You can do. I'm sure you can do it. You can do it. All right. So on Sunday you will do these things for your Monday, or you can just don't do that. So then do that only in the workshop. But the difference of you guys and the other students will be this. You will be able to finish your workshop sooner than the others. Okay. Now this one. So let me do this diagram for you. Okay. A, B. So because of this one, C, D, E. Can I have F? So because F is not, so this is F. So this one is this green color is related to the, where is that? Diagram. Okay, so you will have this solution. So maybe it will help you to, it will be a hint or guide to complete this question. Now, a degree sequence for a graph is, and you will do this one as well. So you can do that. Nothing is complicated. And you can bring your questions to the workshops as well. A degree sequence for the graph is a list of the numbers. One for each vertex is specifying the degree of each of the vertices in the graph. For instance, the degree sequence for the graph consisting of the two vertices connected to a single edge is 1, 1. Okay, so because of, we've got this one, we've got this one. So what's the degree of this one? 1. What's the degree of this one? 1. Some books use the convention that degree sequences are listed in decreasing order, and some other books in arbitrary order. So, but what we will do here is like degree each. So there is no specific order for this. Consider the graph. V hi. This guy here. So server Mac 1, Mac 2, PC 2. So can I have, so now I've got this one here, and so I've got these one, two, three, four, server to Mac 1, okay. Server to Mac 2, server to PC, okay. And Mac 1 and Mac 2. What is the degree sequence of this graph? Is listing in order. So the degree of this one is PC2 is 1. Degree of Mac 1 is just 3. Degree of Mac 2 is 2. Degree of server is 3. So the sequence is 3. What order? In decreasing order. 3, 3, 2, 1. So let's count here. 1, 2, 3, 4, 5, 6, 7, 8. So, so if I have them 3 plus 3 plus 2, 1 plus 1 is 9. So this means I made a mistake somewhere. Mac 2. So this one, Mac 2, 1, 2.
Mac 1 is 2D, 1 is 2.
Okay. All right. So this is 2. So this should be 3 plus 2 plus 2 plus 1, 8. The total summation of the degrees are always even. All right. So now this one, recall that a path in a graph is, did you study path today? All right. A path in a graph is an alternating sequence of the vertices and edges like V0, E1, V1, V2. So this gives you really a path such that each EI connects so the previous vertex to the vertex written in the right hand side of this EI. The length of the path is the number of the edges. Okay, the length of a path is number of the edges. Okay, consider this guy here. So V1 is this one, V1, jail, go, chance, Whitehall, sorry. So, yeah. $13. So here, please be with me. Okay, so this Whitehall chance, jail, go. Okay, so how about the ages? Ages, jail and chance, jail, Whitehall, jail to jail, okay. Chance to go to jail, okay. Whitehall to chance. Okay, so this is one way that you can do for this one. So this is the graph GM. Now, what else? To give an example of a sequence of the vertices, which is not a path. Okay, so can I do this? W G C. So W is just Whitehall, G is the chance, and G is the go, C is the chance. So this is not a path. This is not a path because there is no edge between here. All right, so let me see. It seems that the workshops are sent to us. All right, no, it's not. Now, what is the distance or length of the shortest path in GM? From jail to jail. So jail to jail. So part B. What is that? Okay. What is the path of Whitehall to Whitehall? 1. Guys, please pay attention. Is this 1? W Whitehall to Whitehall. Yeah, we can say it's 3, but you can just essentially you can stay not to move. So you can consider 0 as well. All right. Jail is also can be 0 or 1. Now, J to G. Okay. 1, definitely. Okay, so let's give pause.